Video's going to start with a little ace of base. Yes. Oh yeah, it's not on the recording. I should have left that up while I was doing this. Gotta be the ace of base. That's our goal. Maybe that's the theme today. We should have just gone with today's notes are themed ace of base. And then we saw the sign. We've been watching for signs. We should talk more about signs. All right, calculator handy. So I'll go to my calculator and show you some things on how do you do log base 100. So you should know the basic calculator functions, and they are not crazy. I think you could probably figure out that log of 100, you hit the log button. Pretty nice. And you put in 100. Now, we know it because it's, before the calculator dives in, anything that's just log is log base 10. So pull this up here, log base 10, so this is, we had to evaluate this, it'd be 10 to the x equals 100, so x is 2, we're squaring it. I know that's what it should be. Okay, all the stuff that we just did, we practiced a whole bunch of these. Now, I'm going to put it in here, see if it does the same thing, 100, hit enter, and we get 2. So it's a quick way to evaluate it. Your calculator can evaluate these. All that we just did in that practice thing, so I can go find any one of them. If I can find my, seriously, did I just quit it or something? Oh. Well, anyway, I'll go find it here in a minute. Oh, there. There it is. So any of those that we have that are log base 10, there it is. Log base 10 of 100 is 2. But most of these are not log base 10. In fact, I'd say the vast majority are not. So we have to deal with, what about other bases? How are we going to do that? So, again, that we are ace of bases. Oh boy, I'm going to run with this all day long. Gotta love it. Let's try log base. So the next one is 1/10. So you go log. You got 1/10. Yep. There it is, -1. And if you think about it, x to what power, or 10 to what power gives you 1/10? I mean -1. You're welcome to do it by hand. Maybe I will, just so you know what I'm talking about. So I'll go back in here. Yep, this works. 10 to, I don't know, power equals 1/10. And we all know it's -1. And we did it with the calculator, great. So just trust the calculator can do these. Now natural log is base e. So if I'm going to evaluate these by hand, I'm saying e to the x equals 23.5. Well, now I can't really do it by hand as well. I don't know e to what power is going to give me 23.5. So really, when you go natural log, you got to use the calculator. So we're going to look at natural log of 23.5, which is, just like you'd think on your calculator, ln of 23.5. That's it. And we get 3.157-ish. And some change. So that's it. That's what we do for the calculator. So if I can move this to the side, which I'd really like to, I'd like to have both. I did it. So natural log of 1.48. So I get over here and go natural log of 0.48. That's the end of the story, and I just wanted to get those values. 0.7339. So let's go 0.734. Negative 0.734. Really, what I'm saying is that this thing is equal to negative 0.734. Okay, that's it. That's how that works. Now, what about all the other bases? log base 10, I got a button for that. ln, I got a button for that. When you don't have a button for that, that's the next fun thing that we'll get into. That's coming down the pike. Also, we have to talk about transformations again. So if you come with me here, if you go to Notas, we are going to talk about these transformations. They're just like you would think. So I'm just going to write them in real fast so we can get on to the stuff that I know is less familiar. Like, oh yeah, I know what this one is. This one is left 2. Oh yeah, this one is flip over the x-axis, vertical flip. You could do these in your sleep now, couldn't you? Down 3, because it's outside. Outside of the function, it's a vertical operation. Inside with the x, then it's the opposite. Like this, that's a right one. We have v stretch by 2. And we have up 2. Cool. Same old stuff we've all known. You do that with logs. It's a parent function. It's one of our dirty dozen. We tend to use the natural log form instead of this log base 10, but it applies the same way. When you do calculations with logs later on, it doesn't matter what kind of log you use as long as you're consistent throughout. A log is really just a rule of operations, kind of an order of operations for dealing with exponential type functions. So it doesn't matter which one you use. So natural log, hey, same thing. Right 3, flip over the x-axis, call it a vertical flip. All the stuff you know and love, up 1. This is 1/2 vertical shrink. Left 2, up 3. Done. Got it. Oh, yeah. Thank you, Stephen. Erase that. Glad you caught that, because this is recorded. Gracias. Man. Okay, this one is for Birma. Here you go. What's the shift on this one?
I can't hear this.
What is it, Birma? Do you want to say it? What's the shift on this one, right? Way to go. Don't you even dare. Whew. Almost caught another one. We could have been one less student today. Just kidding. I'm not out to get you guys, I promise. Most of the time. All right, enter full screen. Just keeping you on your toes. So let's do properties of logs. So they do stuff. Oh, this will totally take you back. Remember algebra 2. Always remember your algebra 2. We got a 10 after, yeah? Yeah, we got lots of time. So here goes. Properties of logs. The product rule is, oh dear, I can't keep my pen straight. The product rule is if I have some kind of multiplication inside my log, you can rewrite that log as the sum of a log of the 2 and the log of the 4. So that's a nice way to split her up. Vice versa, sum of same base logs, don't forget they have the same base. Now that doesn't mean, that can also mean this. I can do ln of 2 plus ln of 4. Would it work? This is a fun one to test out. I'd like to try this one. This is where we can pull up that calculator thing. Is it okay to change the base in this situation to see if I get the same thing? Let's see what aces y'all can be on this one. So let's try log of 2 times 4. We know that's log of 8, right? Log of 8. Got that. I don't want this thing. Get that out of here. Can I get that? There we go. Get that out. That key press history is just misleading. So there it is. I have log of 8 entrez, s'il vous plaît. It is 0.9030980. Now let's try the log of 2 plus log of 4. Should I get the same thing? Log of 2 plus log of 4. Yes. Now we're talking. Does it work with natural log? Can I put the other base in on this one? ln of 2. Oh, I just don't know what's going to happen. ln of 4. No. You know why? If you're going to use one type of base of log in your function, your problem, you stick with it through the whole problem. That's the key. Got to stick with it. Can't do it. So annoying. But yeah, that's true. Got to stay consistent with your logs. One log base throughout a whole problem. That was fun checking out. You'll see why that's important later, because we'll interchange them. So now, on we go. This way. Come on, little calculator. This quotient rule, I can take the log base of 8 over 2. I can make it the log of 8 minus the log of 2. So the key is, whatever base you have here, you got to have the same one here and here. I mean, not there, here. So this one, by the way, is 10. Unwritten rule, the law. If it's not written, it's 10. If it is written, use that one. I'm going off the screen, aren't I? You haven't told me about this. Sorry about that. Why have you not mentioned? It's a tragedy. Okay, much better. Right, we're going to pause the video. Building's on fire.